Welcome to problem of the day 188. Find the roots of the polynomial. So we have 3x squared plus 4x plus 2. So to find the roots, we set the function equal to 0, and I'm going to use the quadratic formula. So first we'll take the function, which is 3x squared plus 4x plus 2 equals 0, and then take the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The reason why we're going straight to the quadratic formula is this is going to be hard to break apart and actually set equal to 0 and find the two roots. So I opted to use the quadratic formula because it will be ultimately simpler and easier to do in the long run on this problem. Sometimes it's easier to actually break it apart and do it the other way. So our b value is negative, our b value is 4, but it's negative on this one because negative b there in the formula. So negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times 3, which is the value of a, times 2, which is the value of c, all over 2 times a, which is 3 again here. And this is square rooted, of course, if I forgot to mention that. And then now we can start to evaluate this problem. So we end up getting negative 4 plus or minus, but I'm going to go with the plus route right now, over the square root of 16 minus 24 over 6. And this is a problem here because we got a negative under a square root. So we end up with negative 4 plus the square root of negative 8 over 6, and we can break that apart into under square root of 8 and then the square root of negative 1. We end up getting the imaginary number, so we get negative 4 plus 2 times the square root of 2 to the which is imaginary all over 6. And then what we end up getting on the positive side is, because we broke apart the 6 and the 4 and then the 2 and the 6 value here, so that 2 square root 2 imaginary over 6, since they have a common denominator, it can be broken apart. So you got negative 2 over 3 plus the square root of 2 over 3 imaginary. And then the other root is exactly the same, but instead of added, it is subtracted. So I hope that helps on how to use the quadratic formula. This was kind of a more complicated problem due to the imaginary numbers that this created in the roots.